Hello everyone, this is Ms. Bushra again, and I'm back again with another episode explaining about biology for grade 12. Now, if you remember our last lesson, we talked about bone elongation, bone development, the bone marrow, and everything, and even the structure of the bone. And at last, we're at the joints. Joints is a very, very important part of this skeleton. Why? Because it gives us flexibility to move. If I'm moving my hand like that and start writing, it's because of joints. So what are joints exactly? It's where two bones meet each other, and the structure is designed to make it easier for us to move with it. So let's see. So joints are of three main types. The first thing is there are three main types based on the way that they move. Some of them don't move at all. We call fixed joint. Others have limited movement. They move and they don't move, okay? They are called semi-movable. And then we have movable joints, which they have wider range of movement than the other two. Fixed joints are not that common in the body, but you can clearly see it, and you already know about one, but you don't know this is a fixed joint. If you remember something, we talked about it in the previous video, suture lines, they're in the skull, where the flat bones that were directly formed without cartilage stage join together, see, bones joining, they create suture lines, which are a form of fixed joint. And this is the only example that we have. Some parts of the skull have it, nothing else. Now, there's a note here. It says the joints, they are distributed according to the distribution and the locations. You can find it, in different area. They either become specific to one area that the area is known by them. For example, anytime I say fixed joint, you have to remember that this is skull, because this is a specific area for that. So we have this. Some of them are repeated throughout the body. Others, they are only in one place. Semi-movable joint. A semi-movable gives you movement, but just as much as, something that is super limited, like a twist of your spinal, It doesn't move that much. But look at my hand, it's a movable joint. It moves in a very huge, and wide range. As for the bending, without moving your hip, it is not that much. But if it gives it a flexibility, because your spinal cord is so important to you. If it was like a whole bone, any crack in them will crack the whole bone. But if it's section, and it has these joints that are a bit flexible, just like a spring. For instance, if there's something that is hard in one piece and you put a lot of pressure on it, they might break. But if it was spring, even if you put pressure, it's bending and twisting so that it doesn't break easily. So where do we find semi-movable? In two examples, in the bones of the vertebral column and in the rib cage. See, when we are breathing, our rib cage moves. See, this movement wouldn't be possible if we didn't have semi-movable. And both semi-movable have what? Cartilage between them, and this one also have cartilage connecting them together, huge amount. This one have pads, and they're usually shock absorbent. Shock absorbent means that if anything hits it, an impact comes, it is able to take the impact and try to spread it all over so that it doesn't break easily. Same goes here. It gives it flexibility enough that the chest is going to expand. So according to us, we have three types of joints. Two of them, fixed, have one example, and semi-movable have only two examples. All of the other types of joints are under one category, which is the movable joints. So, like we said, all of the others are movable joints. They have wide range of movement. It means they can move in various directions and orient. Now, we have 5 examples here. The first one we have is a hinge joint. Hinge joint. Then we have the second one, ball and socket. Our third one is pivot, saddle, and gliding. We have 5 types of movable joint. If I say any name of any of these, it means I'm talking about movable joint. Please don't forget about that. There you go. I have a chart here and how they're moving and how each one of them are located in different places. See, a hinge joint, just like a hinge of a door, it's moving on one axis, like your elbow, one axis. Your knee, one axis. But your shoulder joint is a ball and socket. They look like this. There is like in a scapula, a groove like that, and then the bone is a bit round shaped, and they are looking like a ball and socket shape. So we call these this because of their wide movement and their structure, okay? You can move it upward, downward, forward, and rotate it completely. And you have this in your hip joint as well. Write those two, the ones that are not here, knee, and then you have like the hip joint. Then you have a specialized bone in the vertebrae. See, we said that vertebrae are semi-movable, but the uppermost part, the top two, these two here, they are pivot joint. It's a movable joint, okay? Why? Because it lets your head move sideways like that. As for saddle joint, it's specialized to one area as well. It is specialized here, at the base of the thumb. Not here, okay? Here, the base of the thumb. And it allows you to grab things. It's not working like the others. This is what makes you able to hold on to stuff, having a thumb. And what gives that ability? The saddle joint. As for gliding joint, see, in the legs, you have these small bones located here, tarsals, okay? And even in the wrist, the carpals. So what do? These bones are close together, and when you're moving and when you're twisting and bending, they are getting separated from each other in a gliding movement, okay? And then they come back together like that. This is called the gliding joints, okay? There are a bunch of smaller bones. Everything I said here is written. Remember, the hinge joint is moving upward, downward. The ball and socket, upward, downward, forward, backward, and rotates completely. As for pivot, it is side to side, and the thumb is rotating and has a special type of movement, the grip movement, is the saddle joint. The gliding joint is for flexing, being able to separate a bit and come back together at the same time. This is called flexing, okay? Gliding joint is a very good example of that. Here, it shows a complete skeleton and how the bones are distributed here. What we need to know is that if we're looking at an axial skeleton, how many bones did we cross? See, 1, a fixed joint, 2, a pivot, which is a movable joint, and 3, a semi-movable joint, although both semi-movable are on axial skeleton. So this shows that the axial skeleton have all 3 types of major joints. Good. What about the appendicular? Since we have fixed the semi-movable, both of them on axial, didn't we say the rest of it are all movable? So appendicular have only 1 type, which is all the movables. There's these questions here. You can look at it. I've written everything here, and I specified about the vertebrae. What can you find on the vertebrae? Remember, the other top 2 is the pivot, and the rest of the vertebrae is actually semi-movable, which is 2 types, movable and semi-movable. Okay. Now, if we have a joint drawn for us, like I'm going to do it now. Okay, there you go. Let's start with the bones. Didn't we say that joints are bones like meeting together? So we're going to do this. There you go. We're going to draw knee. Okay? Now, the knee has a cap on it. We call it patella, if you remember it. And then it starts off with femur, the upper one, the biggest bone in your body, and then tibia. So we have femur, patella, and tibia. You could clearly see there's another bone close by, fibula, but this bone doesn't contribute at all in the making of the knee joint. Okay, good. Now, the first component of the joints is bone. Second component is cartilage. Cartilage are like helmets. They are making sure that they cover the surface of the bone so that they don't erode, because bones are firm. And if you have two chalks and you're like scrubbing them against each other, the friction is going to make them start becoming powders because they're eroding. So what do we have? The helmet-like protective gear, the cartilage pads, okay? Cartilage here. Good. Now we have that. Then there's another thing. There's a third party here. See, we have ligaments. Ligaments tie bone to bone, like a bandage. I'm not going to draw that because this is a bit special, this type of joint. It has a fourth part, which is the fluid called synovial. Let me write synovial before that. Synovial fluid. Now, any part of the body that moves a lot, it creates friction. So the body always have a protective layer that is going to create a liquid, and liquids reduce friction. Remember that. Smooth surfaces like cartilage reduce friction, and of course liquids do that as a lubricant. So usually what do we have? We have a membrane surrounding it. This is a membrane that creates the liquid for us. What do we call that liquid? Synovial fluid. The liquid is synovial fluid. Up until now, how many things contributed in this? Look, bones, 3 of them, cartilage covering the surface of the bones, and the synovial fluid, which is created by this membrane surrounding it. Good. Now we're heading to the ligament. Ligament, let's say it comes over like that. It has many, each one of them has like a name for itself. What is the job of a ligament? Is to tie the whole structures together. Why? That's a ligament. See, they are not tied with something. They're not connected. There's space between them. If that happens, any impact probably will dislocate it. And this is what we call a dislocation. But ligaments hold them firm like a bandage that's wrapped around them, making sure that this joint remain in its place. This is why we have ligaments. So our third part is ligament. I put a lot of numbers here, so we're not going to mix those. Ligament, which is tying them together, what? Bone to bone. This is a structure of a knee joint, and this is it here. We're going to go through it. Remember, cartilage covering the bone like a helmet, and they reduce friction. Ligaments is a connective tissue, fibrous one actually. It's also, the semi-solid type, and it is holding the joints and stabilize it. As for synovial fluid, is a lubricating material. Anytime you hear lubricant, it means a fluid that reduces friction. Just like oil. If the hinge on the door is rusty, they create sound. Don't we put oil? At this point, oil is a lubricant because it reduces the friction and it is making it easier to move. Don't forget about that. Now, here you go. Femur, patella, and tibia. No fibula. Ligaments attaching them together, and there's also these cartilage parts. It's covering them all. Synovial fluid is right surrounding everything, making it so easy to move. and there is the table. You can take a screenshot if you don't have the pamphlet, and it tells you everything that we said it. Remember the two parts that are reducing friction, because it's so important to have less friction, or else it's becoming very painful and the bone is starting eroding and getting damaged. This is why we have the next part, which is talking about the problems in the joint. Now, sometimes joints swell and they create a lot of pain. We call this arthritis. Okay, arthritis. Now, arthritis are of two types: the rheumatoid, rheumatism, and osteoarthritis, sawafan. Okay, if you see that the way that they are created is different, this is an immune problem. We call it autoimmune. We're going to study it in chapter 3. Autoimmune disease. It's where your white blood cells attack your own body. Okay, attack body. Okay, good. So what happens when that occurs? It is that it becomes inflamed, swollen, stiff, and deformed. This is like a feature of rheumatoid, not osteoarthritis. Now, like we said, it's an autoimmune disease, has nothing to do with age. A kid could have it. Why? Because the white blood cells became aggressive and attacked it. And if this is a normal joint, a rheumatoid, you will see it's swollen. It has nothing to do with the cartilage amount, but the bone is eroded and it starts becoming deformed. What about osteoarthritis? See, when people become older, their body cannot regenerate as easily. See, if our body, when there is friction, of course the cartilage is starting to erode too, although it's smoother for like this, but it could repair itself. Here, when people become older, repairing becomes much harder task. So the first thing you would notice that the amount of cartilage reduced, and this makes the the periosteum touch each other and erode, and they create pain. Remember when we said there's nerves in the periosteum? This is why they have severe discomfort and severe pain. What was the reason? Cartilage became thinner, and it's due to aging, nothing else. At the end of each section, we study something about what if there's a deformality or a disease of this system. And these two examples are perfect for bone, which happens in the joints. So thank you for listening, and I hope you benefited from this lesson. See you in the next one.